Okay, so we're going to talk at this point about what machine learning is and deep learning. Okay, now the term AI, machine learning, and deep learning are often used interchangeably. However, they are not quite the same thing. In fact, it's machine learning and deep learning that allows machines to learn for themselves. Okay, so we'll have to separate them: machine learning and deep learning and AI. Although they are interchangeably ginabaylo-baylo lang, but they are actually three different chickens. Or they're different chickens. Okay, so they are three different things. So essentially, machine learning is a subset of AI, or rather, it is the very cutting edge of AI. AI exists because of machine learning. Okay, that's what it means. This is what this language or this definition means. Machine learning is a specific application of artificial intelligence whereby machines solve specific real-world problems by processing data, right, via neural networks that mimic how a human brain functions. Okay, again, it is a specific application of AI. This is where machines solve real-world problems by processing data via neural networks. Now, these neural networks mimic how human brain functions. To give you a visual representation of that, of what machine learning is, let's look at this.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter, and find us on Facebook.
Well, there you have it. That's machine learning. Now, we are progressing from machine learning into deep learning. So deep learning focuses even more narrowly on a subset of machine learning tools and techniques. Remember, I said earlier that machine learning is the cutting edge of AI. Well, deep learning is the cutting edge of that cutting edge. You get the point? Okay. Example, as I have said, AI, for example, is like your head. And then inside your head is a brain. That brain is the machine learning. Okay? Inside our brain are neural nerves or neural network. That is deep learning. Okay? What enables us to learn is the function of the brain that is being encased in our head. That's the closest I can think of as an example. All right. So to give you an idea what deep learning is, okay, let's look at this video.
Ever wondered how Google translates an entire web page to a different language in a matter of seconds? Or your phone gallery groups images based on their location? All of this is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. In terms of deep learning, this structure is called an artificial neural network. Let's understand deep learning better and how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at the cost of having a much higher volume of data to train our machine. Now, let's dive into the working of neural networks. Here, we have 3 students. Each of them write down the digit 9 on a piece of paper. Notably, they don't all write it identically. The human brain can easily recognize the digits. But what if a computer had to recognize them? That's where deep learning comes in. Here's a neural network trained to identify handwritten digits. Each number is present as an image of 28 times 28 pixels. Now, that amounts to a total of 784 pixels. Neurons, the core entity of a neural network, is where the information processing takes place. Each of the 784 pixels is fed to a neuron in the first layer of our neural network. This forms the input layer. On the other end, we have the output layer, with each neuron representing a digit with the hidden layers existing between them. The information is transferred from one layer to another over connecting channels. Each of these has a value attached to it, and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. Every activated neuron passes on information to the following layers. This continues up till the second last layer. The one neuron activated in the output layer corresponds to the input digit. The weights and bias are continuously adjusted to produce a well-trained network. So, where is deep learning applied? In customer support. When most people converse with customer support agents, the conversation seems so real, they don't even realize that it's actually a bot on the other side. In medical care, neural networks detect cancer cells and analyze MRI images to give detailed results. Self-driving cars. What seemed like science fiction is now a reality. Apple, Tesla, and Nissan are only a few of the companies working on self-driving cars. So, deep learning has a vast scope, but it too faces some limitations. The first, as we discussed earlier, is data. While deep learning is the most efficient way to deal with unstructured data, a neural network requires a massive volume of data to train. Let's assume we always have access to the necessary amount of data. Processing this is not within the capability of every machine. And that brings us to our second limitation: computational power. Training a neural network requires graphical processing units, which have thousands of cores as compared to CPUs. And GPUs are, of course, more expensive. And finally, we come down to training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. So, here's a short quiz for you. Arrange the following statements in order to describe the working of a neural network. A. The bias is added. B. The weighted sum of the inputs is calculated. C. Specific neuron is activated. D. The result is fed to an activation function. Leave your answers in the comments section below. 3 of you stand a chance to win Amazon vouchers, so hurry! Some of the popular deep learning frameworks include TensorFlow, PyTorch, Keras, Deep Learning 4J, Caffe, and Microsoft Cognitive Toolkit. Considering the future predictions for deep learning and AI, we seem to have only scratched the surface. In fact, Horus Technology is working on a device for the blind that uses deep learning with computer vision to describe the world to the users. Replicating the human mind at the entirety may be not just an episode of science fiction for too long. The future is indeed full of surprises. And that is deep learning for you in short. If you enjoyed this video, do like and share it. Also, subscribe to our channel if you haven't yet, as we have a lot more exciting videos coming up. Fun learning till then.
Well, there you have it. Deep learning. I hope you got some information on this video. So now we are going to discuss in general 2 concepts that are vital to understanding how machines are becoming increasingly smarter. Okay, so how do they learn? So there are 2 areas of learning for these machines. The first one is what we call supervised learning. So in supervised learning, this is the most commonly used technique in deep learning or machine learning. And it involves teaching an algorithm or system what you want it to learn. And then it makes use of a set of training or reference data. And the output or end result you want to achieve is already known. The thing is, in supervised learning, think of it as like teacher-student, right? Elementary, okay? Let's say math, commonly used technique. I'll use math as an example. The most commonly used technique in teaching math is teach students how to add numbers, right? Then it involves teaching an algorithm. How do you add numbers? How do you add 2-digit numbers? How do you add 3-digit numbers? So on and so forth. So the student has to follow what we call an algorithm or set of instructions that they want to learn. And then we make use of that training reference data. For example, how do we know that a student is proficient in addition? Because we already trained them and we saw that that student knows how to apply addition on several digits already. Alright, the output actually is the result that we want to achieve, and that is for the student to know how to add, subtract, and multiply. So that is known. Okay, so that is an example of supervised learning. Then there's the other one, which is unsupervised learning. This kind of approach is far more complex, less widely used, but this is where the future of AI is going towards, uncharted territories. There is no training data sets and outcomes that are given. So in short, data sets and outcomes are unknown. You don't know what will happen. AI goes into the problem blind. The AI doesn't know anything. Therefore, the AI will have to learn on its own. And the AI is let loose upon input data with no reference data to learn from. Okay? Unsupervised learning. Good example I could give you is parenting, right? Parenting is a far more complex process, right? Although it's parenting is used, no? But the problem with parenting is there is no training data set or outcomes. Do you agree? You can be a parent. Every one of us can become a parent, but there is no training manual on how to become a parent. There is no training manual on how to raise kids. There are no training manuals on how to deal with teenagers, right? So we don't know the outcome. No matter how we try to be good parents, we try to think we are good parents, but we will never know the outcome of our kids someday. In short, we as future or parents, or you become future parents, you will go into the problem blind. You don't know. There's no silver bullet for parenting. Okay? So this is what we call unsupervised learning. As we go along, we learn along the way on how to become parents. Okay, so that is also same way with AI. Okay. So how are problems solved in the use of AI? Well, most problems require a hybrid solution. Okay. When there is a reference data, or there is an incomplete or inaccurate reference data. You see, in cases like this, a semi-supervised learning technique would be deployed. And this is where the system has to access, or the system has access to some reference data when there is available, but at the same time, it makes use of unsupervised learning techniques to fill in the blanks wherever required. Okay, so in short, we are trying not to corral the learning method of AI into whether we say it is supervised or unsupervised. We are actually using both. Okay, so we are using a hybrid. So the next thing that we're going to talk about is how AI and machine learning is being used in practice. Okay, so how are they being used? Now, as machines become increasingly smarter, they're able to perform tasks that were previously the domain of us humans. Do you agree? Right. Actually, this has with this statement, right? They were able to perform tasks that previously the domain of us humans. This led to the predictions of humans losing their jobs to automatrons, to automated machines, to robots, right? Anyway, we'll talk about that in the next lesson. Are we going to lose our jobs to machines in the future? Now, for now, let's take a look at some of the amazing things that AI is capable of. Alright, so I may not be able to show you the extensive, but to show you to some degree, the importance of AI. Okay, so here it is. AI in marketing. Okay, what is marketing? Well, in simply put, marketing is the way to sugarcoat your products to attract more customers. Okay, so sell something, and sugarcoat it so that people will buy. Right? In fact, we humans are pretty good at sugarcoating. Okay. But the question now is, what if an algorithm or a bot can be made to solely concentrate on the purpose of marketing a brand or company? Okay. In the early 2000s, the thing is, if we search for an online store, if we search an online store to find a product without knowing exactly the name, well, good luck to you. It's gonna be a nightmare finding the product, right? But now it's kind of different. We search for an item on an e-commerce store and we get all the possible results related to that item. Do you agree? You search for the word repeater, for example, and I will tell you, it will give you all items about repeaters, different brands, sizes, form factors. The AI is what we call, or the AI is using what we call a predictive analytics in marketing. Right? Predictive analytics in marketing. To give you an idea what predictive analytics in marketing is, let's look at this.
Hey, and welcome welcome to our brand new series in which we're going to get you up to speed on artificial intelligence for marketing and growth. Predictive analytics is a form of data mining that uses machine learning and statistical modeling to predict the future, based on historical data. Applications in action today are all around us already. For example, banks have been using predictive modeling to approve or decline your credit cards and personal loans. But it's not only that, it's also used for weather forecasting, recommendation engines, spam filtering, and fraud detection. So why should marketeers care? Imagine if you could not only determine whether a lead is a good fit for your product, but also which are the most promising. This will allow you to focus your team efforts on leads with the highest ROI. And this will also imply growing from quantity of metrics to quality of metrics, which leads to focus more time on. A financial services provider can use thousands of data points created by your online behavior to decide which credit card to offer you and when. A fashion retailer, based on the jacket you just bought, can use your data to decide which shoes to recommend as your next purchase, based on historical behavior that other customers have had in the past. But the implications are much bigger than that. Retailers can predict demand and therefore make sure they have the right level of stock for each of their products. Every time we type a search query into Google, Facebook, or Amazon, we're feeding data into the machine, growing ever more intelligent. To leverage the potential of artificial intelligence and predictive analytics, there are 4 elements that organizations need to put in place. First of all, you need to ask the right questions. Which questions am I trying to ask with my predictive analytics? Which metrics am I trying to forecast? Which future behavior am I trying to predict? You need a sound hypothesis to actually test. The second one is having the right data. We've come a long way in terms of data availability. It's been said that 90% of all of the world's data has been generated in the last 2 years. But we still do need complete and clean data sets to arrive at plausible conclusions. It's important for you to figure out what data is available to you and whether it will be sufficient to answer your questions convincingly. Third of all, we need the right technology, whether or not a particular software is right for the problem you're trying to solve. And finally, it's the right people. Without the right people, it's impossible to pose the right questions. Let's look at staff retention at IBM. IBM is using predictive analytics to retain its employees and come up with possible solutions to forego higher turnover. By uploading a structured data file, Watson can spot the common factors in employee dissatisfaction. This then feeds into a quality score for each employee based on their predicted likelihood of leaving IBM. This is what we call people analytics. Next, let's look at supply chain optimization at Walmart. Walmart takes data instantaneously from its system and incorporates it within its forecast to assess which products are likely to go out of stock and which have actually underperformed. Combined with behavioral data from its customers online, this provides a huge amount of data points to help Walmart prepare for increased or decreased product demand. Forecasting this allows Walmart to personalize its online presence, targeting customers with specific products based on their predicted likelihood of making a purchase. We'll go into more depth on predictive analytics in our next episode. Don't forget to hit the subscribe button and be notified when episode 2 is available.
Well, there you have it. As you have seen in our video, as the data set grows, predictive analytics is also getting smarter and smarter every day, right? So you could imagine, since we started with our topic number 1, big data, combining it with topic number 2, Internet of Things. Now we are at a point where machines are using both big data and Internet of Things to predict outcomes. Predictive analytics is also the next big thing. So the next is we are going to look at AI in banking. The use of AI for fraud prevention is not a new concept. Okay. In fact, AI solutions are there to enhance security across the number of business sectors, including banking. Okay, so how they use AI in banking is that by tracing card usage and endpoint access, security specialists are more effectively preventing fraud. Organizations like banks rely on AI to trace those steps by analyzing the behaviors of transactions. Okay, to give you an idea how AI is being used in banking, let's take a look at this.
For 25 years, Visa's artificial intelligence has been getting smarter, and smarter, and smarter, to the point where you probably haven't had a transaction declined for suspected fraud in quite a while. But did you know? Every time you use your card, Visa's AI is learning. Every purchase you make helps Visa get even better at protecting your next transaction. Visa's AI doesn't know your name, or exactly what you bought. It sees activities and patterns to learn what your typical purchase behavior looks like, so that even before you make your first purchase, we can spot suspicious activity. For every attempted purchase, Visa's AI assesses fraud risk so that the bank that issued your card can approve or deny the transaction, or send a text asking you to confirm an unusual payment. Let's take a closer look at how it works. Every Visa account has a profile of previous transaction data. Each time you buy something, the account profile is updated and compared to the spending behavior of more than 3 billion other accounts, making roughly 180 billion annual transactions. This behavior is grouped into clusters, and your account could be in hundreds or thousands of these groups. The activity in these clusters helps Visa understand whether a transaction fits a pattern or departs from the norm enough to be flagged as high risk for fraud and possibly declined by the issuer's bank. So, in 1 week, you could buy a gift for your cousin's wedding, burritos near the office, the tattoo you'll later regret, tickets to a music festival, a return ticket for your business trip to Peru, and hang gliding lessons so you can jump off a cliff while you're there. And none will be declined. Because even though your week seems unique, there are many others out there who also use their Visa accounts to enjoy body art, business travel, and cliff jumping. The more purchases people make, the smarter Visa's AI becomes, ensuring that even your wildest week or very first purchase will make sense to Visa's AI. Or doesn't, resulting in fraud detection when you need it, and approvals when you want them. In fact, since you started watching this video, Visa's community has helped our AI analyze more than 600,000 transactions for fraud, ensuring that your hang gliding lesson gets off the ground as smoothly as your transaction approval.
Alright, so that is how AI is being used in banking, right? Primarily in fraud detection, because when we talk about banking, we're talking about money. And a lot of people can, have a wild idea how they can get more money from banks. Okay, so the next item that we're going to look at is AI in agriculture. Right? Now here's an alarming fact. The world will need to produce 50% more food by 2050 because we are literally eating up everything. Right? So if we cannot produce 50% more food by 2050, well, probably we would expect more hunger and more problems with our food industry. Now, the only way that we can possibly get out of this mess is if we use our resources more carefully. Right? How do we do that? With the help of AI, right? So with the help of AI, farmers can get more from the land while using resources more sustainably. Okay? So let's look at this example in the application of AI in agriculture.
Within the facility, we have got different sensors that are operating all the time, 24 hours. They all go back to cloud. So that gives us data, and then we are able to look at temperature, humidity, light levels, CO2 levels, fertilizer, EC, pH, all the different parameters as required for the vegetables to grow can be calibrated.
As a farmer or as an operator, you have a lot of information sometimes through checking and analyzing of the water quality and animal health. We are trying to create a program, a software that will help to take all this information from different sources and put it together and give you a better picture of your cultural condition. We have so far not really recovered back our costs because, first of all, we haven't reached to the maximum capacity of production, and the second, the cost of doing this business in Singapore is much more higher than any other place. And for the agriculture and aquaculture industry, the resources are very limited. For example, if my pipe broke and I want to buy certain pipe in Singapore, it's not available.
I'm already seeing some startups in Singapore in the agri-food tech space. They are already exporting some of their technology equipment overseas. So Singapore is ranked number 1 in the Food Security Index. So when we export something and it's related to food, I believe the world would feel safe.
Wow. So AI is now invading our agriculture as well. Alright, so the next is the application of AI in education. Now, AI can actually help us primarily as a tool to help develop skills and testing systems, right? As AI educational solutions continue to mature, the hope is that artificial intelligence can help fill the gaps, okay, in learning and teaching, and allow the schools and teachers to do more than ever before, right? Performance issues, no? In fact, AI can drive efficiency, personalization, and streamline academic tasks to allow teachers the time and freedom to provide understanding and adaptability, right? So AI plays an important role. But although this is not yet the time for us to discuss, I'd like to show you how China makes use of AI in their education. And at the end of the video, you tell me if this is how or where AI should be in the field of education, or will you allow yourself or your kids someday to be exposed to this kind of approach, okay, in education. To see what I mean, let's look at this video.
红色是表示你的专注力显示得很高，
Teachers at this primary school in China
蓝色是走神了，
know exactly when someone isn't paying attention.
白色就是你可能跟网络还没有连接好。
These headbands measure each student's level of concentration. The information is then directly sent to the teacher's computer and to parents. China has big plans to become a global leader in artificial intelligence. It has enabled a cashless economy where people make purchases with their faces. A giant network of surveillance cameras with facial recognition helps police monitor citizens. Meanwhile, some schools offer glimpses of what the future of high-tech education in the country might look like.
做出选择吧 ，Good job。
Classrooms have robots that analyze students' health and engagement levels. Students wear uniforms with chips that track their locations. There are even surveillance cameras that monitor how often students check their phones or yawn during classes. These gadgets have alarmed Chinese netizens. But schools say it wasn't hard for them getting parental consent to enroll kids into what is one of the world's largest experiments in AI education. A program that's supposed to boost students' grades while also feeding powerful algorithms.
为了就是国家的这个研究呀、发展呀，我觉得是没有问题的。
The government has poured billions of dollars into the project, bringing together tech giants, startups, and schools. We got exclusive access to a primary school a few hours outside of Shanghai.
2、3，同学们早上好。
To see firsthand how AI tech is being used in the classroom. For this 5th grade class, the day begins with putting on a brainwave sensing gadget. Students then practice meditating.
现在想象我们眉心 The device is made in China and has 3 electrodes, 2 behind the ears and 1 on the forehead. These sensors pick up electrical signals sent by neurons in the brain. The neural data is then sent in real time to the teacher's computer. So while students are solving math problems, a teacher can quickly find out who's paying attention and who's not. A report is then generated that shows how well the class was paying attention. It even details each student's concentration level at 10-minute intervals. It's then sent to a chat group for parents. The reports are detailed, but whether these devices really work and what they exactly measure isn't as clear. We were curious if the headbands could actually measure concentration, so one of our reporters tried on the device.
This is a new technology with still fairly little research behind it.
Theodore Zanto is a neuroscientist at the University of California, San Francisco. He was surprised to learn that this tech, called electroencephalography, also known as EEG, is being used in the classroom on children. It's usually used by doctors in hospitals and labs.
EEG is very susceptible to artifacts, and so if you are itching or just a little fidgety, or the EEG wasn't set up properly so that the electrodes didn't have a good contact, affects the signal.
Despite the chances for false readings, teachers told us the headbands have forced students to become more disciplined.
上课回答我的问题，就是他们的声音会比平常更响亮。
Teachers say the students now pay better attention during class, and that has made them study harder and achieve higher scores.
上课认真听讲，作业做的基本上是全对的。
But not all students are as enthusiastic.
就是自己感觉是脑筋空，我感觉这里有个印，紧的。
This 5th grader, whom we caught dozing off in class, told us his parents punish him for low attention scores. And that kind of data adds a new kind of pressure for students.
想啊，如果在一次考试全班人都考了95分以上，就你考了一个85，你会不会感觉你有一种
Companies we interviewed said the data can go to government-funded research projects. We spoke to parents who were unclear about where the data ended up, and they didn't seem to care too much. Zanto says there's likely no privacy protection at all.
In a classroom, if you're trying to make an assessment of an individual student, you really can't anonymize it.
Experts and citizens alike are sounding alarms about various aspects of the country's huge push into artificial intelligence. These classrooms are laboratories for future generations. And while these new tools may potentially help some 200 million students raise their grades, just how this all works out won't be apparent until they become adult citizens.
Okay, so now we're going to talk about AI in autonomous vehicles. For the longest time, self-driving cars have been a buzzword in the AI industry. The development of autonomous vehicles will definitely revolutionize the transport system. It is because of AI is used to enable the cars to navigate through the traffic and handle complex situations. Also, in a combined AI software and other IoT sensors, such as cameras and GPS, it becomes easier to ensure proper and safe driving. Advanced deep learning algorithms can accurately predict what objects in the vehicle's vicinity are likely to do. Artificial intelligence implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. To show you the capability of AI-driven autonomous vehicles, let's look at this video.
Google has been showing off its work on driverless cars for a few years now, but up until this week, those vehicles always used a human driver or two for backup. There was a steering wheel, brakes, and gas, just in case the computer conked out or a person needed to take over in an emergency. But all that has changed with the introduction of Google's new, completely autonomous vehicles. The prototype car doesn't have a steering wheel or pedals, and passengers are buckled into what are essentially back seats. These cars aren't street legal yet, but while regulators iron out the details of when and where they can drive, Google is intent on showing that automobiles are far safer without any input from us puny humans. Rob Medford, Google's director of safety on the driverless car project, says that more than 90% of automobile accidents are caused by human error. That adds up to around 33,000 people killed every year, the leading cause of death for people between the ages of 4 and 34. Google's newest unit is purpose-built for safety. The form factor means its cameras and sensors have no blind spots and can detect objects for 360 degrees and as far as 200 yards away. The all-electric vehicle tops out at 25 miles per hour and has a front end built of soft foam, tweaks Google hopes will cushion any pedestrian struck head-on by the car. The company acknowledges that an accident is inevitable, but says collisions will be far less frequent and less dangerous than with humans behind the wheel. Google has been putting its first generation of driverless car systems through a series of tests on city streets around Mountain View. It's the same system that's being used in these fully autonomous models. The system can detect various obstacles and even color codes accordingly. Cyclists are red, pedestrians yellow, vehicles are either green or pink. The system so far can detect cones, construction zones, railroad crossings, and yes, it knows when a bicyclist raises his hand to change lanes and then changes his mind at the last minute. Google wants its cars to drive as if a human were behind the wheel, to slow down going into a turn, or to inch up at a four-way stop as a way to indicate it wants to go next. For now, Google's totally autonomous cars are operating just on a closed track, with plans to eventually expand to city driving in Mountain View if and when they become street legal. When that happens, Google's safety systems will likely be tested not just by chance, but on purpose. Insurance fraud is already common among tractor trailers, with scammers getting into accidents so they can sue for damages. If people are willing to throw themselves in front of a speeding semi, imagine what they'll do to a foam cushion car owned and operated by one of the richest companies on Earth. Google knows this is coming, and it's doing its best to play things cool. Every driverless car is going to be equipped with multiple cameras that will record any accident, meaning there will be plenty of evidence to show who's really at fault. As Sebastian Thrue, the original inventor of Google's driverless cars, told the New York Times, the big losers are going to be the trial lawyers.
So there you have it. So those are just some of the applications of artificial intelligence in our day-to-day lives. And eventually we will be seeing more of them as the years progress. So now let's talk about natural language processing and generation. Now let's first define what is natural language processing. Natural language processing is where computers understand human speech. Natural language generation is where computers generate speech. Okay, so again, let's look at the definition. Natural language is when computers understand human speech. Natural language generation is where computers generate speech. Okay, now this is what enables Alexa to understand your 5-year-old when he or she asks to hear their new favorite song for the 50th time that day, and enables Alexa to talk back. You have seen our examples earlier that you can now, thanks to AI, you can now talk to a computer. Then we have natural language generation, or NLG. This is where the really exciting stuff is happening, such as news stories being written by computers. Well, can you imagine? Reporters are now being replaced by computers in writing news stories. In this video, I'd like to show you how the US Associated Press is already publishing corporate earning stories that are written by NLG engines. Let's take a look at this. have it. Machines that are writing stories will be the next thing, right? Then we also have empathetic machines. These are what we call affective computing. This is another area of AI in which it involves machines that are capable of reading our emotions and then adjust their behavior accordingly and effectively making them emotionally intelligent. These are software or programs that are being developed that can analyze facial expression, posture, gesture, tone of voice, speech, and other factors that register changes in the user's emotional state. Okay? So, to give us an idea how affective computing works, AI developer Affectiva Emotion AI technology makes use of this technology, wherein 1,400 brands are already using their emotional artificial intelligence effect of adverts on viewers. Okay, let's take a look at this.
We believe digital content and technology products are made better when they are informed by human emotions. At Affectiva, we quantify emotion to help the world accomplish this goal. We've built the most accurate automated facial coding system that exists today and can discern moment-by-moment emotional state using a webcam. This is the only neuroscience technique that can work online as participants emote in their natural environments. Any face, any place, any interface, in real time. Over the past 3 years, our software has processed more than 1 billion frames of face video of people watching advertisements and entertainment content in over 70 countries. This is the world's largest repository of emotional response to digital media. This research enables optimization, prediction, and evaluation. Optimization of content to maximize moment-by-moment emotional engagement by target population. Prediction of performance indicators such as sales and virality. Evaluation of digital media against normative values by geography and product category. All of this is done in a massively scalable way using our APIs to fuel big data analytics. In the TV and digital advertising world, our emotion data has been used to identify flops and predict at what point viewers will skip. In the movie world, our emotion data has been used to identify the most engaging beats to optimize movie trailers and predict box office earnings. In the entertainment world, our emotion data has been applied to long-format content to quantify comedic value and dramatic engagement, including what happens during commercial pods. In the device world, our SDK enables detection of emotion on platforms such as Google Glass for applications like assistive technology and robotics. All this is done in a massively scalable way using our APIs to fuel big data analytics. How could you use emotion data to build a better product?
So there you have it. The wide range, wide variety of the applications of AI and how it is evolving through machine learning and deep learning over time. And currently, artificial intelligence is in its tip-top shape, alright? When in fact, one of the biggest video streaming company, I'm sure you are all familiar with Netflix, is using AI. So in a real-world application now, aside from the ones that I have shown you, this is how AI is driving the success at Netflix. How is it possible? that Netflix is becoming the byword in video streaming in our homes. Okay, and probably they say the Netflix industry might replace Hollywood in the long run. Alright, so this is how AI is driving success at Netflix.
Netflix offers thousands of TV shows and movies available for streaming. And to help its users weed through an ever-changing catalog, it recommends titles for each viewer, including through those famous, super granular categories like romantic revenge dramas based on classic literature. How does Netflix come up with those genres and create personalized recommendations for millions of users? This is Algorithmics, the space where we explore how invisible, computer-controlled, database sets of rules are making decisions for us every day. As the company puts it, the Netflix experience is driven by a number of machine learning algorithms: personalized ranking, search, similarity, ratings, and more. Because Netflix Quandary is the same as any other online store. It can't offer up its entire catalog at once, so it must curate. But it's different because quality and taste are rarely the same thing. That means Netflix has to go beyond merely recommending top-rated titles and employ an array of algorithms to make sure that their recommendations are tailored to individual customers. What powers these algorithms? It's a mix of data and good old-fashioned human input. First, Netflix takes a look at which titles you watched, searched for, and rated good or bad. And the system shows you similar content. So, if you've watched a bunch of Parks and Rec, Netflix will recommend the likes of The Office or 30 Rock. Netflix also assumes that if your viewing patterns are similar to another user, you both have similar taste. And Netflix will serve up titles to you based on the behavior of those other users. Far more fascinating are the hyper-specific micro-genres, or alt-genres, that Netflix has created, using real live humans who categorize every bit of their content. Netflix has reportedly created some 75,000 categories that weigh tens of thousands of different factors, like romance, gore, time period, even narrative considerations like the morality of the main characters. That's why you might get a bunch of recommendations on your home screen for gory foreign satanic stories, or visually striking nostalgic dramas, or understated romantic road trip movies. It's an odd but interesting way to discover what you really like. And it's a way for Netflix to show you titles it thinks fit your absolutely specific, totally individual interests. So the next time you're so obsessed with a show that you haven't been outside all weekend, remember, you're really binging on the algorithm.
Well, there you have it. That's how AI is driving success at Netflix. Okay, so one more application before we wrap things up. How is AI driving success at Spotify? Well, you're also familiar with Spotify, right? So this is how artificial intelligence is being used to drive success at an audio streaming company called Spotify. Let's look at this.
Every Monday, myself, along with 100 million other Spotify users, receive a playlist containing 30 tracks that seem so perfectly suited for the user that they very well could have been ripped from a cassette tape from a former lover. But the tracks on your Discover Weekly playlist aren't selected by a music-loving friend. No, this intimate musical experience is curated by some very clever computer science.
We're going to make recommendations just for you.
Automated music recommendations are nothing new. Companies such as Pandora, Google, and Apple have been providing a similar service for years, but none have shared the same success as Spotify's Discover Weekly playlist. So just how is an algorithm able to predict what songs are going to get your head nodding? Well, it comes down to two main factors. The first being taste maps. Essentially, Spotify is able to profile each of its users' individual tastes in music using a technology called Echo Nest. This technology analyzes your listening history to get an idea of what genre of music you're into. And it's more specific than just rock and pop. But taste maps are just one part of this two-part recipe. The second ingredient is all to do with playlists. There are over 2 billion playlists on Spotify, each representing a unique musical taste. And it's these playlists that form the core of what makes Discover Weekly's recommendations work. Spotify's algorithms are able to analyze all 2 billion of these playlists along with any playlist that you've created and then proceeds to fill in the blanks. Essentially, if the algorithm sees that there are 2 of your favorite songs on a playlist along with a third song that you haven't heard before, it'll recommend this new song to you in your weekly playlist. Spotify's algorithms then filter all of this data. The songs that have been selected from similar playlists to yours and that also match your music profile, and then it determines which ones you likely haven't heard before by interpreting your music history. It can be a little unnerving sometimes when a song comes on Discover Weekly that seems perfect for you. And it's even more bizarre to listen to somebody else's Discover Weekly playlist, a playlist optimized for somebody else's unconscious and unique music preferences.
Can you please change the radio station?
But this is Grand Funk Railroad. You guys back there know Grand Funk, right?
But why do we like different styles of music in the first place? If a song's good, shouldn't everybody enjoy it? After all, everybody's ears interpret sound waves in the exact same way. Well, according to Valerie Salampour, a neuroscientist from McGill University in Montreal, our brains create musical memory templates based on past musical experiences. Essentially, your brain releases dopamine, which is the body's feel-good drug, when it listens to music that is similar to other music you've heard in the past. This would explain why, if you've never listened to classical music before, the first time you tune in, odds are you won't enjoy it. It also explains why a band that fits a genre that you're familiar with is also so enjoyable, even though you've never heard it before. Of course, your brain's able to form new templates. It'll just take longer for them to form the more unfamiliar the music is to the brain. Meaning, if your partner is really into heavy metal, give it a go. After a while, there's a high chance that you'll come around to liking it. Who knows, it might even end up on your Discover Weekly. Although Spotify Discover Weekly runs the music recommendation game at the moment, it represents something much larger. The mechanics behind what goes into delivering those 30 tracks to 100 million plus users every single Monday gives us an insight into how people will experience, enjoy, and discover music in the future. Hi guys, thanks so much for watching my video. I just wanted to point out that Spotify did not sponsor me to make this video. I was just genuinely curious about how they made my Discover Weekly playlist. If you did enjoy this video, please subscribe. That would mean a lot to me. We've got some very exciting stuff coming up, so make sure to hit that bell next to the name of our YouTube channel. And in the meantime, check out some of our other videos, and I will see you.
AI is now the driving force behind successes of not just startup companies, but well-known companies now, all right? So in the near future, we will be seeing more of this, and I don't see any foreseeable future where AI will be, removed from the industry, okay? With that, we land down our discussion. Right? What does artificial intelligence and machine learning technology means for you as an information system student, as a technology learner? Well, the thing is this: AI technology may seem beyond the reach of any average business, right? Nobody, for example, Foodman across our street or Save More, right now they may not have the resources to really make use of artificial intelligence, but the nice thing about it is platforms like IBM's Watson are opening up AI and machine learning to a much wider audience. So probably in a few years time you will learn AI as part of our curriculum, right? Now, there are many startups who are applying this technology to a wide range of industries and applications. So now they're, making use of that. If you have time, look for IBM Watson's business application over YouTube, and you will see that there are a lot of applications that IBM Watson can be used for. So whatever industry you're in, it is likely that artificial intelligence will have some impact on the coming years. Although there are still some genuine concerns about what this mean or what this may mean for people's job in the future, that is going to be our next topic. It is important that, just keep an open mind, because there are going to be a lot more incredible opportunities that artificial intelligence will bring. Alright, so that's it. So thank you for your time, okay? And I'm now open for any questions if you have some. So thank you.